Compare the following two problems. Which of them is more interesting? Problem A, calculate the area and perimeter of the following rectangle, or Problem B, draw three rectangles with area 24 centimeters squared. Calculate their perimeters. I think that most teachers, or tutors, or mathematicians would likely reply that Problem B is more interesting than Problem A. In a typical question like A, we look at a particular instance of a class of objects, here it's the class of rectangles, and then we perform some operations related to its properties. A question like Problem B does a slightly different thing instead, fixing a property of rectangles, here it's the area, and asks us to generate examples to study and observe, seeing what we can learn from them. And it turns out, we could learn quite a lot. For one, we could learn area varies as length and width vary. Say, if I double the length whilst keeping the width the same, then the area also doubles. In that varying of the lengths, you might also become more convinced of a statement like, all squares are rectangles, but not all rectangles are squares, since a square naturally appears as an element of this variation. And then there's the perimeter. Even though all three of your rectangles have the same area, their perimeters can all be different. That's a genuinely surprising and rich observation, that fixing one measurement leaves the other completely free to vary. There's also something difficult about generating examples that forces you to contend with what you're doing. It's very hard to be varying lengths and widths and not accidentally realize this notion of the 2 degrees of freedom we have with rectangles, or that area is something about painting the inside of the rectangle as opposed to perimeter, which is walking around the rectangle. Even better, sometimes, if we're lucky, we might also end up retrieving the procedure from Problem A along the way. Here, to confirm whether a guessed rectangle actually has the desired area, you need to calculate the area. The quote-unquote simpler question is secretly embedded inside this richer one. It sort of just comes for free. These sorts of questions, where you fix some property whilst another part varies, are well documented in the education research literature in what is known as variation theory. What is perhaps slightly different here is including these open-ended questions, what I'm calling generating problems, where the task is specifically to produce an instance of an object with desired properties. Here are 4 more examples so that you really get what I mean. 1. Write down 2 numbers with exactly 4 factors. Now 2 with exactly 3 factors. Now 2 more with exactly 2 factors. Can you write down a number with exactly 1 factor? Here's a different one. Write down a function with 0 stationary points. Now one with 1 stationary point. Now one with 2 stationary points. 3 stationary points? Could you generate one with n stationary points? Again, here's another one. Draw 2 cylinders with a volume of 100 pi centimeters cubed and calculate their total surface areas. Do cylinders with the same volume have the same surface area? Again, and the last one. Write down 2 matrices, A and B, where A times B is not equal to B times A. For now, the main focus of this channel will be to generate these sorts of problems across a variety of contexts in the secondary school curriculum. Welcome to Asking Different Questions.